All right, this is lesson 1.5, and we're going to be talking about solving and graphing inequalities and also writing and solving compound inequalities. So just a quick review here on your inequalities. This says that x is greater than 4. All right, and so when you graph that, we want x to be all the values that are larger than 4. So we would have an open circle at 4, and it would be everything greater than, to the right then, of 4 on the number line. If it's greater than or equal to 4, we would have it be equal to 4, so it would be a closed circle, and then everything larger than 4, so everything to the right. X is less than 4 would be an open circle at 4, and everything just below 4, like 2.9999, everything to the left then of 4. X is less than or equal to 4, it would be a closed circle at 4, so it would include 4, and then everything to the left of 4. Remember, with greater than or less than, the arrow always points at the smaller value. Now let's write some inequalities. X is at most 25. That's saying that the highest it could be is 25. Otherwise, x is going to be less than 25. So it would be less than or equal to 25. So 25 is the maximum. X is not equal to 25, just as x is not equal to 25. The next one says x is greater than 25, so we write it this way. And the next one says x is less than 25. So here we have to write an inequality, represent the sentence. So if we want to write 5 fewer than a number is at least 12, well, we start with a number, we'll call it x, and we want 5 fewer, so we have to subtract 5. And that is at least 12. So that's like the minimum it could be. So it would be greater than or equal to 12. If something is at least, it has to be that number or more. So this value is greater than or equal to 12. In the next problem, it says we have to write an inequality that represents this. The quotient of a number and 3 is no more than 15. Quotient means we're dividing. What are we dividing? A number and 3. So x divided by 3, it's no more than, so it's got to be less than or equal to 15. And then you could solve that real quick. Let's talk about how we'd solve this. Here, x is getting divided by 3, so we would multiply this side by 3, or 3 over 1. Multiply this side by 3. So these cancel, so x is less than or equal to 45. All right, the next one, I didn't have it erased. That's an important problem. That's one that you'll want to know probably for your ACT test and maybe even your MCA test. It says your scores are 95, 92, 89, and 86 on your tests. What score do you need to get on your next test to get a 90% or better in the course? So what we want to do is look at our test scores. We have a 95, a 92, an 89, and an 86, and we're going to take one more, so we'll call that x. Now, when we take the average of all of those tests, and when I say average, I really mean the mean of the tests. So you add them all together, divide by 5, because there are 5 of those. We want that answer to be greater than or equal to 90. So we want our mean to be greater than or equal to 90. So to solve that, we have an expression in the numerator, so we'll throw parentheses around that. We're going to simplify the numerator. So we'll combine like terms, add those numbers together. So that is 362 plus x. All of that is divided by 5. That's greater than or equal to 90. And now we multiply both sides by 5. That gives us 362 plus x is greater than or equal to 450. And then what we do is we subtract 362. So x is greater than or equal to 88. So you have to have an 88 or better to get your average up to 90% or better for the class. All right, here is an absolute value inequality. We're going to, not absolute value, just an inequality, and we're going to solve that. So we have negative 6x if we distribute, plus 15 plus 1 is greater than or equal to 4. We want to simplify the left side, continue simplifying it. So now we're going to combine like terms. And we have to isolate the variable term, so we'll get rid of the 16. So subtract 16 from both sides. And now we're going to divide both sides by negative 6. Now the one thing you have to remember when you're solving inequalities, that if you divide both sides by a negative number, or if you multiply both sides by a negative number at any point in the problem, your arrow switches directions. And so that's your answer. X is less than 2. So if you graph that, you have a number line, you would have an open circle at 2, and it's going to be everything less than or smaller. Now, one thing to keep in mind when you're graphing these, if you ever get confused, as long as the inequality has been arranged so that the letter is on the left, the direction that the arrow goes here will be the same direction that the arrow goes here on your graph. But that only works when you have the letter on the left. Now we have a word problem. A digital music service offers 2 subscription plans. The first has a $9 membership fee and charges $1 per download. The second has a $25 membership fee and charges 50 cents per download. How many songs must you download for the second plan to cost less than the first plan? Well, the first plan, it costs you $9 plus $1 times the number of downloads. So we'll call it 1 times X. The second has a $25 membership fee and it charges 50 cents per download. So 50 cents times the number of downloads. How many songs must you download before the second plan is less than the first plan? So we want this one to be less. So we have the arrow point at what we want to be smaller. The first plan then would be greater. So now we solve this inequality. So you have 1x is greater than 0.5 times x plus 16. Oops, I kind of turned those around here. So 25 minus 9 is 16, and then 0.50x. Now let's subtract 50 cents times x from each side. That gives us 0.50x is greater than 16. And then lastly, we will divide by 0.5. So x then is greater than 32. So the number of downloads, once it's greater than 32, the second plan will be cheaper. So for example, let's say I just put 32 in. I would have right here 9 plus 32. That would give you 41. And if I put 32 in for x on the other side, that would be 25 plus 0.5 times 32. That would give me 41. So when I buy 32, the costs would be equal for both of the plans. But when I step it up and I buy 33, so when I'm larger than 32, so if I buy 33, if I plug 33 in, I would have 9 plus 33. That would be $42 for this one. And for the next one, that would be $41.50. So at that point, with 33 downloads, the second would be less than the first. It should have been $41.50, sorry, $41.50. All right, just another quick one. Plumber A charges $75 for a service call and $40 per hour. So 40 times X, the number of hours. Plumber B charges $50 per hour, but no service charge. How many hours must a plumbing job last for plumber A to cost less than plumber B? And you would set it up like this. And this time I'll solve it this direction, but I'll show you what we have to do at the end. So that's saying that 7.5 is less than x, or x is greater than 7.5. So like I said, it's easier to work with, I think, when the letter's on the left. So we're going to switch everything around. So when you switch the numbers here, it's pointing at 7.5. You need to switch the arrow. So when x is greater than 7.5. So the number of hours then for a plumbing job to last for plumber A to cost less would be more than 7.5. All right, we'll do a couple special cases. So first we're going to simplify each side. Now there are a variety of ways this could happen, but let's say we'll go ahead and get our letters on the left. We end up with, oh, they cancel out. The x's cancel. -2 is greater than 7. Is that true? No. So whenever you're working a problem and you come up with a false statement, you write, there is no solution that will make that true. So no solution. All right, next one, let's first simplify. So we'll distribute. So 10x minus 7x is 3x. And when we subtract the 3x's from both sides, you have -15 is less than or equal to 8. Is that true? Well, yeah, it's true. It's always going to be true. And so when a problem happens like this where you're working it out and the x's completely cancel out and you end up with a true statement, you would say that there are infinitely many solutions for x. Next, we're going to look at a compound inequality. So what is the solution if 7 is less than 2x plus 1 and 3x is less than or equal to 18? So what we're looking for is an x that makes both of those true and graph the solution. So 7 is less than 2x plus 1. Let's start by getting our x by itself. 2x is greater than 6. And again, I want to switch this around. So it says x is greater than 3. So that's the first one. 3x is less than or equal to 18. So x is less than or equal to 6. Now when we graph that, we have 3, 4, 5, 6. So first we have x is greater than 3. So open circle at 3 because it doesn't equal 3. And then x is less than or equal to 6. So equals 6, and it's everything less. And so the area, or the solution then would be everything that works for both. So it would be where they overlap. And so that would be your solution. Now again, this is kind of like a sandwich. You could write it this way too. X is less than or equal to 6. And x is greater than 3. That's another way of expressing that solution set. Next one is an OR, and so we have to get k, the values of k that work in one or the other. So if we subtract 7, k is greater than or equal to -1. Here, if we subtract 8, k is less than -5. So when we look at how that will look on a graph, we have -5 here, -1 here. K is less than a -5. Would be -5 and everything to the left. It doesn't include -5, so we have an open circle. Or k is greater than or equal to -1. So that's a great OR, so it's everything to the right of that. So great ORs have I think of it as an OR at the end. Your solution would go one direction or the other direction. All right, let's talk about writing a compound inequality. Here it says the wind speeds of a tropical storm are at least 40 miles per hour, but less than 74. So basically they go from 40 just up to 74. So to write that out, it's kind of a range of values. So put the x in the middle. Make the arrows both point the same direction to the left. The minimum it would be 40. And it says at least 40, so it would include 40. but less than 74. So when you do this, when you write these compound inequalities, these and problems, put the letter in the middle, make your arrows both go to the left facing the same direction, put the smaller number on the left, the bigger number on the right, and then you just have to read carefully to see if you have equal to in either one of them. So that is your solution there. Let's talk about how you solve a compound inequality. You have 5x minus 2 is greater than 3 and less than 7. So we want to get the x by itself in the middle. So if you do something to one part, you have to do it to the both of the other parts. So we have 5 is less than 5x, which is less than 9. And from there, again, we want the x by itself. Right now, x is getting multiplied, so you do the opposite. You divide by 5. And so x is less than 9/5, which is 1 4/5. You could leave it as 9/5 or write it as 1 4/5, and greater than 1. So like if you graph that, if 1 is here and 1 4/5 is right here, it is right between there. So you'd have open circles, and it's everything in between. And that's the end of this lesson. Let me know if you have any questions. Thanks.